This video is all about isomers and drawing organic molecules in different ways, and so that there's more information or it becomes more simplistic for you. So representing organic molecules, we've got the structural formula, there's the condensed structural formula, there's the carbon skeleton formula, there's ball and stick model, and there's space filling models. You don't need to write this down. So the structural formula would be how we have continued to draw them. So far, the condensed structural formula is you're showing those single bonds, except for you are condensing it. So you've got CH3 to represent the carbon that had the 3 hydrogens, this next carbon that has the 2 hydrogens, then that's where you'd have the CH2, and then the CH3 at the end. So it's just showing you what atoms are present and how they, like, teeny bit of how they're arranged. So a carbon skeletal formula, this becomes a shortcut. So every point on here is a carbon. And so you know if there's only one bond off of it, that you would have 3. You know that if there's 2 bonds coming off of it, that there'd be room for 2 hydrogens. Same thing here, 2 coming off, you'd have the 2 hydrogens and then the CH3 at the end. You've got the ball and stick model, which is like the models that we've used or that you've seen. And so here we've got CH4. This is showing you the geometry of it. Space filling model is just showing you the, including electron density in there. So another example of this, we have propene. The structural formula, we have CH2, CH3. Here we've got the 1 double bond. So if we look, CH2 double bond to the carbon, the single bond to the hydrogen that has, or the single bond to the carbon that has those 3 hydrogens. So here in the carbon skeletal formula, you would know, hey, there's a carbon here, there's a carbon here, there's going to be a double bond between them, the single branch off of it. Again, ball and stick model, here you can see that there's the separation, that there's the 2 bonds that are there. And so if we're going back to our MS1, where we're looking at the intramolecular bonds and those angles with the Vesper theory, you can see, hey, there's 120 degrees between 2. There's only 3 atoms coming off of it. Same thing here. Here we've got the 4, so then that's where this carbon itself would be tetrahedral. So space filling model, again, you can see it there. So something called the structural isomer, so molecules that have the same formula but different structures. And so for instance, we have hexane that could look like this. We also have different options of how those 6 carbons could be arranged. The C4, C, and G8. We've got one structural isomer here. We have a different structural isomer that's here. So they, just depending where that carbon or that double bond is. And so here we can have multiple different structures of how butane can potentially look. So isomers are going to have the same formula, but different molecular structures, which is going to lead to different chemical and physical properties. Okay, so here we've got malic acid. We've got make medications more stable. Again, you've got the 2 carbons. All that's changed is for these groups of HO2 with our carbon and COH2, so same thing over here. So intermediate in the citric acid cycle that allows us to make energy from food. So different uses for something that would have the same number of carbon atoms, same number of oxygen atoms, same number of hydrogen atoms present. If you look here, if we have pentane gas, we have C5H12, which has a boiling point of 36 degrees. So here, we've got a different pentane. I don't know why, I was thinking propane. So here we've got, again, our 5 carbons with the same number of our hydrogens, but in this case, our boiling point is 9. So if we think of C5H12, there are 3 different isomers that can form. C7H16, or heptane, there'd be 9 different isomers. And so the more that we get, so with our 20 carbons and our 42 hydrogens, there are more than 300,000 different ways that they can go together, or isomers that can be formed. So we've got straight chains hydrocarbons, and then we also have our branched chained hydrocarbons. And so we've got isomers butane that have different structural differences and property differences. And so our butane here, we've got lighters, torches, curling irons, straighteners, stoves. Isobutane, more environmentally friendly. It's a safe refrigerant and propellant for shaving products. And that is it.